Okay, so I wanted to start today's quick lesson with a very seemingly basic question. What is an exponent? So you've probably seen exponents before. They look like this right here. We would read this as 2 to the power of 4. So that number up top is what we call an exponent or a power. That basically gives us a hint about the number of times that we're going to repeat multiplication. The number on the bottom, the big number there, is what we call the base. That's the number that's going to be repeatedly multiplied. So this kind of makes a little bit more sense, in a very, very basic sense of talking about 2 to the power of 4 means 2 times 2 times 2 times 2. 2 is going to be multiplied by itself 4 times, a total of 4. 1, 2, 3, and 4. Okay? So again, this is what we call expanded form. Basically, we're going to need that to actually develop some interesting rules for simplifying exponents. Okay? So the first rule would be that if you multiply two powers with the same bases, how would we be able to simplify? Well, let's use our expanded form to deal with this. This stuff in the first set of brackets would be 4 to the power of 5. So that's 4 times 4 times 4 times 4 times 4. It's a lot of 4s. And then this second set would be a little bit shorter, it'd be 4 times 4. We would ask ourselves, well, what does that mean? Well, that means 4 times 4, 5 times, and 4 times 4, 2 times. But we're going to multiply both of those by each other. Now, remember, an interesting property about multiplication is that order doesn't really matter when we only have multiplication bouncing around. So now that I've written this in expanded form, we actually see that this is in reality 4 times 4 times 4 times 4 times 4 times 4 times 4. How many 4s do we see? Well, how many underlines did I have? I had 7. So that actually simplifies to be 4 to the power of 7. So we can actually simplify two powers with the same base when we're multiplying by adding the exponents. But the base, it stays the same. Okay, so yes, we are multiplying 4 by 4 by 4 by 4 by 4. That's fine. That's the base. That's the number that's being repeatedly multiplied. The number that's changing is the number up top here. And you can notice that 5 plus 2 does work out to be 7. I'll show you a few examples in a second, but on to rule number 2. So rule number 2 is kind of the opposite. So in mathematics, the opposites are always important to have a good grip on. If we divide powers by the same base, you could probably guess what the rule is, right? So multiplication means adding the exponents, then dividing probably means the opposite of addition, which is subtraction. But let's try and use these in expanded form to see what's going on. Again, here we have a different base of -5. Now we'd be careful, it's -5 in brackets, right? We're going to multiply -5 by itself. I guess I don't even need my multiplication signs because they're in brackets. There's 4 of them, right? They're all on top. And I'm going to multiply that by -5 squared, which is -5 times -5. And if we remember much about fractions, we know that actually we can divide the top and the bottom by the same number in order to simplify. So if I divide the top by -5 and the bottom by -5, those -5s disappear. I'm left with 1s. And I can do the same with the top there and the bottom there. I'm left with 1s. So if I look at this carefully, I actually don't really need to count that stuff on the top. I don't really need to count that stuff on the bottom. It actually works out to be -5 times itself, which is -5 squared. And again, that has to do with this minus this. Right? So again, the opposite is true by subtracting the exponents. And again, the base is going to remain the same. Okay, so the base is always going to stay the same because we didn't multiply those numbers together. We're just simplifying. We haven't evaluated yet. So with rule number 3, another interesting concept here, another interesting rule is that if you raise a power to a power, you can actually simplify by, well, let's take a look at this. 2 to the power of 3 to the power of 4 means take 2 to the power of 3 and multiply it by itself 4 times. So I'm just going to write that out in sort of semi-expanded form. And I could expand these 2 to the power of 3s if I wanted to, but why not just use rule 1 in order to simplify this now, right? So this would be a base of 2, but an exponent of what? 3 plus 3 plus 3 plus 3. Well, that works out to be 12. Now, an interesting thing you might notice is that 3 and 4, 3 plus 3 plus 3 plus 3, that's 4 groups of 3, which is basically multiplication, right? So we can simplify by multiplying the exponents. And again, the base remains the same because we have not evaluated. We're just simplifying, okay? So what I'd like you to do is consider these three examples. If all of that was a little bit foggy, go ahead, rewind, rewatch, watch as many times as you want. But if all of that wasn't foggy for you, I want you to consider these three example questions that are a little bit harder, but I want you to consider these three examples. Go ahead, give them a try, pause your video now. Alright, so I want to take these down one at a time just so we're not distracted. You can feel free to fast forward if you want to see the answers to all three. So with our first example, we see that our answer is -2, the base doesn't change again, to the power of 8. How we get that 8 is 3 plus 5, because again, this means 3 -2's multiplied in unison, and this means -2's, 5 of them being multiplied together. So in total, we'd be multiplying 8 -2's together. Example B, similar. You could have an intermediate step of writing that out in expanded form, but me personally, I really don't want to write 3 to the power of 5 times 3 to the power of 5 times 3 to the power of 5 times 3 to the power of 5 like 10 times. That would take up way too much space. And that's kind of the heart of the reason why these simplification rules are useful, right? We can write down 3 to the, or -3 to the power of 50. That's a massive number. Don't have a calculator, don't need to figure it out, don't need to evaluate, but we know that we can do mathematical operations with it, and that's what's kind of handy. All right, so -3 to the power of 50 because we have 5 to the power of 10, right? So 3 to the power of 5 to the power of 10, sorry. So we multiply both of those exponents and get our new exponent. The very last example is kind of where it gets a little bit more difficult. We do have to still kind of follow BEDMAS. So if you think about it, evaluating a power of a power has to come before multiplying powers, because a power or an exponent should come before multiplication. So that's why we had to actually do this first step here, because we are doing basically exponents within BEDMAS. You can see I kind of cheated on the bottom here. I did do the multiplication on the bottom, 3 to the power of 7 times 3 to the power of 3. So we add both of those together. Up at the top, we actually multiplied both of those together to get 6 and 6. Then finally on the top right here, we are going to add the 6 and the 6 because we are multiplying with two same bases, and 3 stays the base, and this is still the same on the bottom. We haven't changed anything. Our final answer is going to wind up being 3 to the power of 2 because 12 minus 10 equals 2. So you can see how that really complicated looking expression with very large numbers, right? Like 3 to the power of 7 would be a huge number. We can actually simplify it down to 3 to the power of 2, which we all should know is 9, right? If we wanted to evaluate. So again, if I had asked you to evaluate, I would have asked you to figure out that the answer was 9. And again, if you have a pretty cool high-powered calculator, yeah, you'd be able to punch all those numbers in, hit equals, and you would get 9. But something tells me actually you'd be punching numbers in a lot longer than you would be simplifying if you follow those very simple rules. So believe it or not, that's the video for tonight. So really simple today. Tomorrow we're going to advance this a little bit more and start talking about what happens when we're dealing with variables.